Hello everyone, myself Hanasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of Laplace transforms. So let us begin with the first topic, that is integration of Laplace transform. Let us write the statement: if Laplace of f of t is equals to f of s, then Laplace of f of t upon t. Now we have t in the division, so we have to write it as integration s to infinity f of s ds, right? So now let us begin with the proof. So we know the definition, that is Laplace of f of t, that will be equals to f of s, and that is equals to integration 0 to infinity e raised to minus st f of t dt. Fine, so this is our definition. Now let us integrate both the sides with respect to s. Here you can see we have to integrate with respect to s, and limits are s to infinity. So on integrating we will get integration s to infinity f of s ds, that is equals to integration s to infinity and this integral, right? So now what we can do is we can interchange s and t, right, because they are independent variables. So let us change the order of integration. So it will be equals to integration 0 to infinity, integration s to infinity e raised to minus st f of t ds dt. We have changed the order of integration because our variables are independent. Fine. So now let us integrate this function with respect to s. So this t is constant, right? So on integration we will get integration 0 to infinity e raised to minus st upon minus t f of t, and limits are s to infinity, right? Now let us put the limits in this bracket. So what we will get, integration 0 to infinity will remain as it is. This dt also will remain as it is. If you put infinity, e raised to minus infinity will be 0. This minus, now just put s, right? So your answer will be e raised to minus st upon minus t, right? This s we have to replace in place of s only. Fine. So on simplification, what you will get, integration 0 to infinity e raised to minus st f of t upon t, right? So this is what we are getting. Now we know whenever we find Laplace of f of t, we have integration 0 to infinity e raised to minus st f of t dt. That is, whenever we have f of t, we write it as Laplace of f of t. So in this we can write it as Laplace of f of t upon t. So in short, we can say that Laplace of f of t upon t is equals to integration s to infinity f of s ds. Fine. So let us understand this using examples. So we have to find Laplace transform of 1 minus cos 2t upon t. So whatever is in division, multiplication, you have to firstly ignore that and find the Laplace of this term. So Laplace of 1 minus cos 2t. Just use the linearity property and put the formulas of Laplace of 1. So that will be 1 upon s, and Laplace of cos 2t will be what? Minus s upon s square plus 4. So this is your f of s. Done? So now let us bring this t. So Laplace of 1 minus cos 2t upon t. So whenever you have t in the denominator, right, you have to apply this formula, that is integration s to infinity f of s ds. Now put this f of s, right? So what we will have, integration s to infinity 1 upon s minus s upon s square plus 4, right, and ds. Now let us integrate this. So integration of 1 upon s will be what? Log s, right? Now suppose I want to integrate this. So we all know the formula, that is integration of f dash of x upon f of x will be what? Log f of x. So firstly we need to put derivative of this term in the numerator. So derivative is 2s, so just multiply and divide by 2. So here now finally the integration will be 1 upon 2 log s square plus 4 using this formula. And now the limits are s to infinity. Now let us firstly simplify this. So what we will take firstly LCM. So we will have 2 log s minus log s square plus 4, right, and upon 2 s to infinity. Now 2 is constant, right? So let us put it outside. So 1 upon 2. Now this can be written as what? Log s square. So log s square minus log s square plus 4. That is log a minus log b. So what we will get? Log s square upon s square plus 4, right? And the limits are what? S to infinity. Now you can see there is an indeterminate form when we put infinity as the limit. So in order to simplify this, what we will do? Take out s square firstly common from the numerator and denominator. So here it is s square only, take out here common s square, so it will be 1 plus 4 upon s square, right? And the limits are what? S to infinity. Now this will get cancelled out. Now if you put infinity, this will become 0, right? And finally what will remain? Log 1. So half into log 1 minus, if you put s in place of s, you will get this only, that is minus log of s square upon s square plus 4, right? Now we know the value of log 1 is 0, right? So final answer is minus half of log s square upon s square plus 4, right? If you can take out minus sign on this side, the answer will be what? Half log, you have to reverse it, s square plus 4 upon s square, right? So this is your final answer. Now let us move on to the next example. So we have to find the Laplace transform of this, that is cos at minus cos bt upon t. Again ignore this and find Laplace of cos at minus cos bt, right? So we know the formula of Laplace of cos, that will be s upon s square plus a square, and this will be minus s upon s square plus b square. Now again we'll name this as f of s, right? Now bring this t in the denominator. So Laplace of cos at minus cos bt upon t will be equals to integration s to infinity f of s ds. Now just by putting f of s, what we will get? Integration s to infinity s upon s square plus a square minus s upon s square plus b square ds, right? Now again we have to set the derivative of this in the numerator. So again multiply and divide by 2 in both. So again apply this formula, that is integration of f dash of x upon f of x. It will be what? Log f of x, right? So what we will have? 1 upon 2 times. The integrations of both the terms will be log s square plus a square, and here it will be log s square plus b square using this formula. So now log a minus log b, that will be again log a upon b. So log of s square plus a square upon s square plus b square, and your limits are s to infinity. Now before putting the upper limit, that is infinity, again we have to simplify it by taking common s square. So if you take out common s square from the numerator and denominator, what will remain? 1 plus a square upon s square upon 1 plus b square upon s square, and your limits are s to infinity. Now as you put infinity, this will go to 0, this will also go to 0. So what will remain is log 1 minus, if you put s, then it will remain this only, that is log of s square plus a square upon s square plus b square. Fine. Now we know log 1 is 0. Take this minus right here. So what we will get? Finally half log of, reverse it just, s square plus b square upon s square plus a square. So this is your final answer. Okay. So now let's go to our next topic, that is Laplace transform of derivatives. So if Laplace of f of t is f of s, then Laplace of f dash of t, that is of derivative, will be s f of s minus f of 0. Next, Laplace of f double dash of t will be equals to s square f of s minus s f of 0 minus f dash of 0. So in general, Laplace of nth derivative of f of t will be equals to s raised to n f of s minus s raised to n minus 1 f of 0 and so on, f raised to n minus 1 f of 0. Right? So how to remember this formula? Firstly, you have to write s raised to n f of s. So whatever is the power of the derivative, that you have to write first, right? Now just decrease the power of s. So you will have s raised to n minus 1 and lastly it will be 1, right? Now just start putting f of 0, f dash 0, etc. So lastly what will remain? F raised to n minus 1, 0. So just decrease the powers of s and increase the powers of small f. So this is the process to remember the formula. Okay. So now let us start with the proof. Laplace of f dash of t we have to find out. Apply the definition, which is Laplace of f of t, that is integration 0 to infinity e raised to minus st f of t dt. But here in place of f of t we have f dash of t, right? So put that. Right now we will use the formula of integration by parts, that is integration u v dx, u integration v dx minus integration du by dx integration v dx whole dx, right? So here now you have to assume this as our v and this as our u and apply the formula of integration by parts. So you will get this, right? Now finally put the limits in this. So e raised to minus infinity will be 0. So that is 1. If you put 0, e raised to 0 is 1. So here we will have f of 0. So finally we will have minus f of 0. Take this s outside, minus minus plus. So plus s times integration 0 to infinity e raised to minus st f of t dt. Now we know that this is equals to what? F of s. You can see from here. So finally we have proved that Laplace of f dash of t is equals to s f of s minus f of 0. So similarly, let us find Laplace of f double dash of t. So this will be equals to minus f dash of 0 plus s times Laplace of f dash of t. Just put the formula of this, that is s f of s minus f of 0. Simplify it, so you will get s square f of s minus s f of 0 minus f dash of 0. So in general, we have this formula, right, which I have stated before. That is the Laplace transform of nth derivative of f. So let us understand this using few examples. So we have to find Laplace of f of t and Laplace of f dash of t, where our f of t is e raised to minus 5t sine t. So let us find the Laplace transform of this first. So again, whatever is in multiplication, division, you have to ignore that and find the Laplace of the remaining function. So let us begin and find the Laplace of sine t. So it will be 1 upon s square plus 1. So now bring e raised to minus 5t into sine t. Now here if you see e, we have to apply always first shifting theorem. That is, you have to replace s by s minus a. Here the value of a is minus 5. So you have to replace s by s plus 5. Fine. So on replacing, you will get answer as 1 upon s plus 5 whole square plus 1. Right? Now name this as our f of s. Okay. Now we have to find the Laplace of what? F dash of t. We know the formula, it is s f of s minus f of 0. Right. Now firstly let us find the value of f of 0. So this is our function, just put t as 0. So e raised to 0 is 1, but sine 0 is 0. So the value of f of 0 is 0. So this is gone, just put this. So the final answer is s upon s plus 5 whole square plus 1. Right? So now let us move on to our next example. So we have to find Laplace of f dash of t, where our f of t is this function, right? So now you can see the function is in two parts. So we cannot apply the formulas directly. So we will use our definition. So firstly we know that Laplace of f of t is integration 0 to infinity e raised to minus st f of t dt. Let us split this into two sub-intervals. So first will be 0 to 5, next will be 5 to infinity. But in this you can see the function is 0, right? So 0 dt. Here the function is 3 in 0 to 5. So we will have 3 times e raised to minus st dt. Now this is gone, right? Take out 3 outside and just integrate this. So integration will be e raised to minus st upon minus s, right? And your limits are 0 to 5. So minus 3 upon s. Now just put upper limit. So you will have e raised to minus 5s minus. Now put the lower limit, right? So if you put 0, e raised to 0 will be 1, right? So this is our answer of what? F of s. Done. So now let us find the answer of Laplace of f dash of t. So we know the formula, it is s f of s minus f of 0, right? So now firstly let us multiply this inside, okay? S times we will have what? Minus 3 into e raised to minus 5s minus minus plus. So plus 3 upon you have s. Right? Now you have to put the value of what? F of 0. You can see 0 is included in this sub-interval where the value of the function is what? 3. So minus 3. Now these two s will get cancelled out. 3 minus 3 also will get cancelled out. So your final answer is minus 3 e raised to minus 5s. Okay. So I hope you have understood both the topics. Thank you for watching.